Now if we take the same circuit, but instead we have a battery running into a light from the negative into the negative of another battery that we are charging, and the positive to the positive. If this one was dead and this one was fully charged, then there would be a voltage gradient through the bulb, and thus it would charge the battery up to 2 volts less than whatever the battery was at. Now if we connect 2 of them in series, producing 24 volts into a light, and we have 2 of them in parallel, so that the negative is connected to the positive, and the negative goes through the load and then into the negatives of however many batteries you want. I've heard it will work with any number, well above 10. And the positives go into the positive of the run. And as you can see, there's negative 24 volts going into the lamp, and then negative 12 volts. So there's a 12 volt gradient. So there will be 12 volts at 1 amp going through this light. Now if we look at a standard charging system, say a wall outlet, you have your batteries and they're hooked up to a generator at the power company, and inside the generator there's a magnet spinning in a field. Now inside your batteries, assuming these are NiCads, you have a nickel positive contact and a cadmium negative contact and a potassium hydroxide electrolyte. Now inside the battery, the electrons are coming down the wire and the ions are inside the battery, and then the electrons come out. Now, electrons are small, they have negligible mass, and they move at near light speed through the wires or around them. The ions are big and they have more momentum, and it takes them time to build up speed. So the electrons are coming down this wire at light speed, and then they hit the ions, which are slow, and they traffic jam. And then there's a huge differential in current or voltage that develops at the negative pole as you're charging it. So what happens is, during this spike, it causes a lot more voltage, but in a standard induction circuit, there's only ever one switch on. So the difference that we did is when we hooked 2 batteries up to 2 batteries, we created a pulse chain, a very rapid sequence of pulses from one battery bank to the other. And in doing so, we changed the characteristics of how we charged it. Because in a standard charge, it would take hours, like I mentioned. And in my charges, like you just saw, took seconds. And it's still glowing very brightly. That is real usable power that we are using to destroy these dipoles that we've created into the 0-point field. So if you want any more information about it, just look up Tesla's 4-battery switch. I'm not violating the conservation of energy laws, because this isn't a closed system. These batteries are charging cold, where regular batteries charge hot. If something is hot, that means it's giving out energy. If something is cold, that means it's taking in energy. So there is efficiency loss through the battery, albeit very small because NiCads are fairly efficient. But there's also energy loss from the system that I'm taking power from. So I'm not violating any laws of conservation. I'm merely starting a sequence of high voltage pulses and continuing it in a closed circuit through a battery, through a load with resistance. It acts as a diode, preventing any backflow, so that it can't be charging by back EMF or any of the other anomalies. It has to go straight through. So the only theory that I can think of to possibly support that is that there is a train of pulses going through, and once I've opened the door to the 0-point field, all I have to do is keep taking energy from it to keep it open. Well, I hope that explains all your questions. If you'd like to talk about it or discuss any of the theory, feel free to send me a message, or if you want to read up on it, check out panaceauniversity.org. It's got lots of information. Have a good one.